with another interview question. Let's hope it works this time. Um, so there's a few here. This one is pretty short to be a Verilog question, but basically, um, you want to multiply by a number by 24 with minimal adder. So what you can do is you can left shift by 3, and that'll multiply by 8, and then you would multiply that 8 by 3, so 1, 1. If you multiply a number by 1, 1, it should synthesize that number and then that number left shifted by 1, and it'll add it. So there's one adder. If you want to implement it manually, you could basically do this number times 8 plus this number times 16, which is equivalently the same thing as what I just described. So left shift by 3, and then another signal where you left shift the same signal by 4, so a fan out of 2, and then you add those together, and either solution gives you one adder, which is probably the minimum amount of adders. Otherwise, if you don't have a single adder, then you can't really do any multiplication unless it's a power of 2 in digital logic design. Anyway, so instead we're going to do this one. This one's kind of drawn out, but it's always good to practice this one. All right, so this just says, this is just Modulo 5. I'm thinking if there's any parameters. No, there's no parameters. And then you just do like this. And then you would just do bitstream, and you can ask the interviewer if there's an enable on the bitstream, which will complicate things. In this case, I will complicate things to make it more exciting for myself and the viewer. And then output, I need logic on all these. Yeah. Divisible by 5. Why do I spell it out? I don't know. I feel like I like spelling it out because I don't really want it to like mix variable numbers with like indexing numbers, but that's just like a me thing. So, okay. And divisible by 5, and then let's just initialize these bad boys. Bitstream is, I don't know. And then enable is 0 for now. Yeah, I might test a few cycles where enable is 0 just to make sure nothing's happening. All right. You know what though? I'm not gonna have the enable, even though I want to make things complicated, because this says every cycle, and so every cycle meaning every cycle after reset. So I think enable is maybe too complicated. Though if I was interviewing a candidate, I probably wouldn't ask for enable, because if it's the first question I want to test it out, maybe I would ask them to add the enable and how they would modify afterwards. So if we have time after that, I might just show how to do that. But for now, let's just assume that every cycle things are shifted in. Right, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and then let's just do modulo 5, I modulo 5, and then let's do clock reset, and not reset. And one might be wondering, why interview if you have a job, why change jobs? And there's a study that says if you were to change jobs once every couple of years, you earn more in your lifetime income than someone who were to stay at the same company. So it's like, do you want double the money, or do you want to not double your money? Yeah, I think the answer is pretty obvious. So no compile issues here. Yeah. All right, so let's just start with the flop stuff because I feel like that's a little easier for my brain to wrap around, and then also trigger my brain to know exactly what variables I need because I don't remember a lot. All right, so yeah, let's okay. So if you had to have the enable, you'd actually have like an idle or a none state, because if at the beginning of time you haven't even shifted it in a zero, then there's nothing to shift in. Likewise, there's like perhaps some empty cycles later on, or yeah, yeah, it's a little cleaner that way if you have an idle cycle. But I guess now that I think about it, I don't know if it's necessary, and I'm kind of glad. I'm not working on that yet. So let's just do 1, 2, 3, 4, and then 0. And then these would just mean like modulo states, mod state, and then mod state next. So like 0 just represents if the current number is modulo 0, 1 modulo 1, 3 modulo 3. Okay. Yeah, and then if you have enable signal, then you would just, if enable begin end on this one. So, and then always comp, and it's just an FSM thing. So you just have case of the current state you're in, and then yeah, end case, and then yeah, there's no begin here. Cases, unlike if statements, where it's just case end case. So that's something to keep in mind. So if I'm at 0, then what's my mod state next? If bitstream is 1, then stay here because 0 multiplied by 2 is, sorry, if if it's 0, then 0 multiplied by 2 is 0, so stay at 0. If let's just flip by 1, then if this is a 1, that means we're doing a times 2 plus 1, where a is like your number. So, mod 0 times 2 is 0, but then plus 1 is 1, so you go 1 here. And then 1, begin, end. And then it's just basically like just mundane math. I'll do a video later that might be more interesting because I don't know how to solve it as of right now, and probably as of the next video, where I'll probably do like, what if you have to find out if the number is divisible by some random number like 13. Like in a real environment, you're not gonna write a 13 state machine unless, how do I not get demonetized? Well, unless let's say you're not efficient. But anyway, 1 here is if I multiplied 1 by 2 plus 1, that's 3. If I just multiply it by 2 by left shifting by 1 with b stream 0, then that's 2. Okay. Actually, I already copied it. I don't know why I copied it again. But so 6 plus 1 mod 5 is 2. So we stay here, and then 4 otherwise. 3. So 6 plus 1. Oh, sorry, actually, if I'm at 2 and then I multiply with 2 plus 1, I go back to 0. Otherwise, because 5 mod 5 is 0. And then here is actually 2, because 3 times 2 plus 1 is 7. 7 mod 5 is 2. And then otherwise, 3 times 2 mod 5 is 1. I'll probably double check it because I'm not confident on arithmetic. So this is 3 plus 1, 4, and then this is 3, and that's it. In an on-site interview, I wouldn't bother too much, but I might make a statement where it's like, oh yeah, in a production environment, I might do like default begin, and depending on the company and the politics in that company, you might just assign to X, and then you just make an assertion saying like, yeah, things should never be X. I think it's capital, but I forget. And then that way you'll know if your state machine's in error, and then some people eat that up, but the current company I work at really hate X's because they don't like verifying things properly. I think that's it. Let me double check this. So 1, 0, okay, 3, 2, 2 times 2 plus 1 is 5, 5 is 1, 0, 4, and then this is 4, 7, 2, 6, 1, 8, 9, 4, 8, 3, 2, and then 6, 1. Go. Yeah, I can't believe like that's the only way you get there. Okay, let's see if this compiles. Print bars and clock. So one thing is I need to assign output, and then you can ask your interviewer like, hey, like, do you want me to output the answer in the same cycle as B stream or the cycle after? So you could say, so in this case, so for example, if you want a cycle after, then you just say mod state 0, right? And then if you say mod state next, which is this particular specification I'll just add, I want to know the answer this cycle. So I'm not going to wait for the thing to flop if I'm here and I'm saying, well, okay, I'm streaming this bit in, and we're going to go to 0. This means that existing number, we have enough information this cycle to know that it's 0, so just output it. If the spec requires, and you just, instead of mod state next, you just do mod state. But be sure to ask for cycle clarification. And the reason is because, in real work, you kind of want to know when, like, if something's timing critical, and therefore if you need to add a flop or you need to do some other ninja moves to get around it. So, so in this case, because we are going to get the answer the same cycle, I will go ahead and clock it afterwards. Right. So, what do I want to display? I want to display bstream, and I want to display my answer, mod 5. And then, is there some internal? Yeah, probably like mod state next. And then mod state next, not mod state, because I want to know how the state machine's evolving. Probably do D because it'll just correspond to the enum here. And like, yeah, let me maybe do like So this is text vector is actually something that I will shift in the bit stream. And then this is so that I can actually see in decimal what the number is. Otherwise, like ones and zeros, I can't really parse it that well. So divisible by 5, and then I modulo 5 mod state next, and then test vector, and then test vector. I'll just say 0 for now, but then I'll do some stuff with it later. But I just want to make sure this even compiles. Does not be stream. Cannot be driven. Oh my god. Yeah, you probably caught this. You probably caught this. All right. And all right, so that's okay. And then now what I want to do is maybe I just do this. Right? And then so this should be divisible by 5 at some point, but I don't know what point. This is, let's say, to the power of what is 65535? 32. Nope. Okay, so 16, so about like 17 bits. Okay. So maybe I just want to do like for int I equals 0, I is less than 20, I plus plus. Okay, and then what I want to do is first I want to stop the reset, and then I want the bit stream to be what? If it's left shifted, like let's say this was like ones, something like that, right? We probably want to shift in the MSB first, because this is the thing that'll get multiplied, and added, multiplied. Like the oldest thing gets multiplied and added. So it's really the MSB of the test vector that'll get hit. So really I need to do 100 here because I don't want to. Yeah, actually like 20 is probably okay. Actually, let's just do 100. Who cares? And then so 99 would be the maximum, and then minus I would be my B stream. And then so my B stream's like this, right? Then all I need to do is print vars and clock. So I put a wait one here for the combinational logic to work through. This will show me the state, and then it will show me the test vector. This is probably buggy and too ambitious to start with this, so if this doesn't work, I might yeah, okay. What's going on here? Print. What? Oh, 62, my bad. 62, because I'm missing a semicolon. Probably like the bottom 20, yeah, like here. And yeah, I guess I do see this, but then it's like the problem is like, is this random chance or is this actually something that is uh, working? So let's do this. Um, let's do like 98 to 0. And I am shifting in B stream. Okay, so perhaps instead of test vector, which I can just, it's a constant, I'll just do like current number. See what this does, if anything. Okay, great. It's X because do I need to initialize it? Yes, do. Oops, this is 32 bits. Let's run it again. So tick 0 means assign all bits to 0. Oh, this is quite nice. So there's two mod 1s because of this. This one is divisible by 5. And how you tell it's divisible by 5 can be referenced through this Schoolhouse Rock song, which I'll put in the description. But basically, if it ends with a 5 or a 0, it's divisible by 5. So welcome to math class. All right, let's try a couple more, and then let's get out of here. Let's just erase this, and then it shouldn't be divisible by 5 when in the last case anyway, so it's not. But I guess it apparently goes here. But let's do maybe 20. 20 is a bit easier to digest. Okay. Yep. And then perhaps we could do what's a nice prime numbers? 20. 31's a prime number, pretty sure. I was trying to get a case where it won't have it. Yeah, 1111 is 15. Okay, well, I guess it works. Yeah, and then on that disappointing note, I'll see you in the next one.